Right now, next one. So next one is horizontal range. Okay, right. Now path of the projectile is completed and velocity after some time t completed. Next, time of descent when it reach the ground, time taken to reach the ground. That is time of descent complete. Next one. So let us discuss that horizontal range. So range of the projectile, projectile is like this. So at a certain height h, okay, certain height h, and projectile is projected from this point. Let us take initial velocity u, and it is moving like this. We know that. Okay, so so during the entire journey from here to here, the maximum horizontal distance traveled with the body. So range means the maximum horizontal distance traveled by the body is called the range. So that is right. The maximum horizontal distance or displacement or whatever. The maximum horizontal distance traveled by the projectile, traveled by the horizontal projectile or traveled by the body while it touches the ground. While it touches the ground. Means what? Ground will touch a time ki maximum horizontal displacement how much? That the horizontal displacement is called the range. Ground is called the range. So denoted by capital R. Clear? Now we have to derive the formula for the range. Okay, right now. So range means horizontal direction, the horizontal displacement. That's why along horizontal motion, we know that ux is equal to u. Clear? Ux is equal to u. Right now, ax is equal to, we know that 0. Time t is equal to how much here? Time t is equal to how much? Time t is equal to time of flight or time of descent we have to take because of entire journey. That's why here time t is taken as td, otherwise time of flight, total time of journey. Okay, and next sx is equal to capital R because of horizontal displacement. Okay, so from these four parameters, that means from these four kinematic quantities ux, ax, t, sx. So we can write sx is equal to ux into t plus half into ax into t square formula. Okay, right. Sx is equal to r. Ux means u, t means td, plus half, ax means 0, td square. The total term becomes 0. R is equal to u into td. Otherwise, we can write r is equal to u into. Already we find out time of descent to td is equal to root of 2h by g. Clear? Therefore, range of the horizontal projectile r is equal to u into root 2h by g. Understood? Or equal to u into root 2h by g. Finally, you conclude that one thing. What is that one thing? Time of descent formula root 2h by g. Range formula u into root 2h by g. Range depends on initial velocity, but time of descent not depends on initial velocity. That depends on only vertical height or top of the right. This is the range of the projectile. Next we have to find that based on these two, velocity of particle. One second, ma. Right. Velocity when it strikes the ground. The velocity when it strikes the ground. See, velocity when it strikes the ground means this one now. Velocity when it strikes the ground means at this point. Okay, okay, at that point. I can read the diagram once again. Tangents. So this is the ground. This is the tower. Okay, the body projected like this initial velocity u, and it is moving like this. This is the velocity. Okay, and the path of the projectile is like this. Okay, now at this point it is the ground, because of it is the ground. At this point, and it is the Vx, and exactly vertically downward Vy, and the velocity is moving like this. Okay, final velocity, this is the V. Now they are asking velocity when it strikes the ground, here this velocity. Now at this point velocity means what? Vx is equal to u only, and Vy is equal to gt, am I right? And here V is equal to, V is equal to Vx plus Vx I cap plus Vy is equal to Vx I cap plus Vy j cap. We already find out at any time. But here at any time only, that condition only. But at this point means total time of journey we have to take, we have to consider. That means time of descent we have to take it. Am I right? So at this point they are asking what is the final velocity when it reaches the ground. So velocity when it strikes the ground. Okay, strikes the ground. Then the velocity when it strikes the ground, before going to that, Vx is equal to, then Vx is equal to always u only, because of horizontal component same. Next Vy is equal to general formula gt. Previously already we find out gt at any time. But here Vy is equal to gt. That's it. Vy is equal to g into, then t means root of 2h by g. Am I right? T means time of descent. At this point means total time of descent. That's why t is replaced by root of 2h by g. Then that equal to, it can be written as, you can write 2gh. Then 2 g square h by g will be cancelled. That means root of 2. One second. Root of 2gh. So, okay, Vy is equal to root 2gh. Now the resultant velocity V bar is equal to Vx I cap plus Vy j cap. So now V bar is equal to, then Vx means u I cap plus Vy means root 2gh j cap. Okay, this is the vector. Okay, now magnitude V bar is equal to root of u square, because of Vx square plus Vy square magnitude. Otherwise I component square take. So u square plus root 2gh whole square means 2gh1. Root 2gh whole square means 2gh. This is the vector, velocity vector. This is the magnitude. This is the magnitude. And one more thing is there. This is what? Direction of velocity when it strikes the ground they are asking. Direction of velocity when it strikes the ground means this one only. This one. Let us take theta when it reaches the ground. When it reaches the ground, let us take theta. Sorry. Let us take theta. Same direction of velocity. Tan theta is equal to opposite by adjacent component Vy by Vx. Vy component, what is that? Vy component root 2gh. So here root 2gh by u only. So theta is equal to tan inverse root 2gh by u. Okay. Theta is equal to tan inverse root 2gh by u. Okay. So the velocity at any time over, velocity when it reaches the ground over. Two concepts, velocity concepts. Okay. Right. So once check it now. Okay, right now. I hope you understand. Right. Next. Finally, we conclude that in this today's class. So once we have to recall all those things in the today's class. ఈ రోజు చెప్పిన క్లాస్లో ఏమేమి నేర్చుకున్నామో let us discuss once again, right? Right. So in this class, right? No, no, in this class, you know that horizontal component of velocity always u after time t. After time t, okay, after time t, and before going to that, this is the horizontal projectile. First of all, horizontal projectile means ఏదో ఒక హైట్ నుంచి త్రో చేస్తారు, అది కూడా హారిజంటల్ గా, ఓకే, అండ్ ఇట్ ఈస్ మూవింగ్ లైక్ దిస్. ద పాత్ ఆఫ్ ది projectile is parabola. Understand? Path of the projectile is parabola, and path equation, okay, after time t మనకు ఇచ్చినటువంటి ఫార్ములాస్ ఏంటంటే పాత్ ఈక్వేషన్, హారిజంటల్ ప్రొజెక్టైల్ పాత్ ఈక్వేషన్ రీకాల్ చేసుకుంటే చెప్పండి. హారిజంటల్ ప్రొజెక్టైల్ పాత్ ఈక్వేషన్ y is equal to kx square, where k is equal to g by 2u square. Clear, right? And after that what we get? Initial component of velocity, sorry, final component of velocity after time t, u only, at any time u only. Final component, vertical component of final velocity is gt, okay, gt, and velocity vector equal to ui cap plus gt j cap, that's over. And magnitude v is equal to root of u square plus g square t square, u square plus g square t square, and theta, angle made by the velocity vector with horizontal axis, theta is equal to tan inverse of gt by u, clear, okay. This is the velocity after any time. And velocity when it strikes the ground, when it strikes the ground, right, when it strikes the ground, v equal to vx is equal to u only, vy is equal to gt only, but it can be written as root 2gh, okay. V bar is equal to, what is the v bar? U square plus 2gh here, because of t value we can substitute. So, and theta is equal to here tan inverse of root 2gh by u. The velocity when it reach the ground. And we know that remaining formulas, time of descent is equal to root of 2h by g, and range formula r is equal to u into root of 2h by g, okay. So you learned all these things in this today's class, okay, clear? Okay, clear. Now let us discuss one previous year question. So I can write, then you can solve it, okay. Write once, check it and recall, okay. So how to find the velocity vector? Velocity vector at any time t, okay, velocity vector at any, so vx is equal to u only, here vy is equal to gt, depends upon time, 1 second, 2 seconds, 3 seconds, so question is done, okay. Here velocity, here, so two places velocity we find, okay, right now, right, next. Let us write one question. I hope that, where is that question? Right now, February 2023 shift 1 question, JEE mains question. JEE mains 2023 question. So I can try to write: a child stands on the edge of the cliff 10 meters above the 10 meters above the ground, 10 meters above the ground, and throws a stone push a stone horizontally with an initial velocity with an initial velocity 5 meter per second. 5 meter per second. So they are giving neglecting the air resistance. Neglecting the air resistance. Air resistance. మనం టోటల్ ప్రొజెక్టైల్ మోషన్ ఎంటైర్ కాన్సెప్ట్ నన్న ఎయిర్ రెసిస్టెన్స్ నెగ్లెక్ట్ చేసి చేస్తాం. ఎగ్జామ్షన్స్ లో ఆల్రెడీ వి డిస్కస్డ్ ఇన్ దిస్. నెగ్లెక్టింగ్ ద ఎయిర్ రెసిస్టెన్స్, the speed they are asking, the question is the speed with which the stone hits the ground, with which the stone hits the ground. That means the speed with which the stone hits the ground will be. That is the question. Will be in meter per second they are asking. In the bracket they are giving g is equal to 10 meter per second. Giving b equal to 10, g equal to 10 meter per second. No. Option 1 20, option A 20, option B 15, option C 30, and option D 25. Okay, option D 25. Right, and you can try to solve it, and the next class, okay, let us discuss this question. Okay, they are asking the speed with which stone hits the ground means striking velocity. They are asking last to discuss చేసే ఒక కాన్సెప్ట్ స్ట్రైకింగ్ వెలాసిటీ. v is equal to root of u square plus 2gh ఫార్ములా వచ్చేస్తుంది మనకి. ఓకేనా, u is given already and g is given, h is given. h means 10 meters. Okay, clue కూడా ఇచ్చాను నేను. Okay, then you can try and you can go through other problems based on today. Time of descent completed, velocities completed, range completed, path equation completed. Okay, and based on that, what are the constants in this concept? Initial velocity constant, g acceleration due to gravity always vertically downward constant, initial velocity u is constant, initial horizontal component constant, final horizontal component constant. Okay, ఈ కాన్సెప్ట్ అంతా బేస్ చేసుకుని you can go through the different problems or different worksheets. Okay, from the different books you can collect the questions from this concept. Okay, right, ma? Okay, right, thank you, bye.